Hello Earth, welcome to episode 20 of season 4 of Making Cell, a series of videos where I record myself designing and implementing a programming environment called Cell. If you're just tuning in for the first time and you want to know what this is about, I recommend you go check out github.com/autocodenl/cell. I'm pasting now the link in the description of the video. So, I was in the process of understanding, Happy New Year by the way, I was in the process of understanding how cell.respond works for the tests that I already have there. I was doing that last episode and I was going pretty slowly, but today I'm a bit fresher than last time. So let's see if adding some brain power to the process will help it. So the first example is this one. It's the first put of a valid sequence. This one. Just basically I'm summing 10. So I'm summing 1 to 10 and I'm getting 11. And it actually even works if I remember correctly. So no, it doesn't work. Oh yeah, it does work because it allows me to go past this. So this is actually working, which is great, but it was working actually anyway. And I have a lot of logs, but I have way too many logs. So what I want to understand is, let's just have a systematic way to look at this. Yeah, that's a question, an open question about who would like cell, but let's not talk about that now. Yes, today's the 3rd of January of 2026. So we have this. So we had done this before. We can perhaps express this as data, as for data. Have the context, the target. Can do it like this. So this is the initial thing. The path itself is 11 plus 1, 10. Sorry, it doesn't work like that. For a minute I forgot how for data works. So this one is, let me switch the music back to the previous one. It's an amazing track, by the way. Sorry. So, come on. So once I am done with this, I can get the current value. I can do value. Current is nothing because there's nothing there. On the new value, is what? Maybe I can here I can say from do execute. Actually, I could do this and just get the diffs, right? Yep. So yeah, I'm setting +1. Interesting. It doesn't start with 11. Because if I go here, to be hard to find, I should be. Let's not waste time and quickly do this. Yeah. Where is it? Here. This is the first one, right? Yeah. It does this path once, it does it again, and then it finally goes in here. It also goes here, but all this time it's not doing any puts. That's so weird. Ah, yes, because the puts are being done by cell.do. Oh, I see. No, that's not what I want to do. Sorry. Actually, we can follow this. We don't need to run this. I mean, we can run it in our heads, right? So this makes a call to execute here. And what do I get back? I have the definition here. I have output here. It just returns something empty when you're not done. Yeah, yeah. Existing value path. Yeah, you're only going to return something that is not empty. So I think I had this written down in the annotated, but what I'm relearning, cell do execute will respond with empty text until it finishes. A do execute will make its own puts directly when it is expanding, when it's expanding, making an expansion. Those calls to put from a do make the sequence, make a respond go through those new paths again. I think I need less logs, not more, but I need some logs. Maybe I can make it like this. And here I just need to do something like this. So we're doing 11 at plus 110, and then we're executing plus 1 do. Let's actually do the puts. Oh yeah. Actually, we can just do the diffs, right? Yeah. Okay, that's look at how few puts, how few diffs. Oh, because I didn't return. Silly. Okay, now yes. Okay, these are much better logs. Okay. Here. Okay, here we start. So we respond first on the first path of the data set, the data space, which is this one, 11 plus 110, perfect. And then you execute this. Now this is interesting. Why am I going back to respond here? Without putting. This is so strange. Why am I not? Why do I have 5 straight puts? It's like, yeah, these are not syncing, unfortunately. I think it's because one of the logging functions is lower, so I cannot do it like this. I have to do it like this. Yeah, otherwise it makes no sense, right? Am I getting the same result? All the puts are at the end? No, it just goes again. How is it responding and not putting? I don't get it. How can there be paths like this if we didn't put anything? It's an absolute mystery to me. I don't get it at all. There are no... because it's a call to cell.respond. That's what's going on here. I need to do it here, I think. Yeah. Yeah, I had to do it before the recursive call. Yeah, okay, now it makes sense, I think. Wait. Right. Dialog. Actually, can I do it with pretty here? Respond. Okay, we're in business. 11 add plus 1, 10. Execute this. Then you add 11 colon in 10. So you're already starting the expansion. Perfect. Yep. Then you start again from here. So you re-enter. You execute this again. You already have the argument, so you move to the next one. This is fantastic. Okay. I have a better sequence here. It will be response at plus 1, then execute plus 1 at do actually I would like something else here. No, actually, sorry, but back. Almost there. Let's go back to the top. Wow, it's snowing. All right. Yep, give me the console logs, please. Sorry, the clocks. At the top of respond. No, that's not the one I'm looking for. I'm looking for this one, the one at cell output. Using the brain is faster than using the hands. No. I want the context path. Yeah, at 11. The where would be 11. Oh, context. Okay. And then we have a put, or you can even call it diff. I love these diffs. Yes. Oh, this is strictly correct for data here. This is a list. Okay, now same thing from the top. This is the second one. Same thing. And then, well, instead of diff, I could just call it put. It's a bit. $11, yeah, this the step. One at, yeah, int 2 1. Perfect. Okay, and that is an interesting one because it starts to do a respond. Okay, because the expansion goes above the at when re-entering the data space to respond, we hit that one, the expansion first instead of the call. That's how the thing moves forward. Why didn't I do this when I was designing this the first time? It's just so silly. To honest, like take a concrete example and follow it until you really get what the hell's going on. I guess I was desperate to make it work. Maybe in season 7 I'm gonna realize I was being very silly now, and on season 5. Yeah. Okay, but this is really good. At least for my standards. So we have, now we're responding on this one. Yeah, 1 at +1 at int. In this case, let's make some spaces here to distinguish the cycle. Notice this one, there's no execute here. Yeah, because I'm expanding this one. Of course, that doesn't require. Here we can call it instead of execute, I referenced in the context of 11. No, wait, the context is not just 11. Or is it? No, the context, yes, it's definitely 11. And the value path is yeah, reference. The value path is int. Yeah. First put. Oh, this is the first put, right? No, that's the original. I'm not counting it. Then yes, this one, int, and then yeah, the context is 11 add do 1. Exactly. No, not add. I need to figure out what to call the column. Expand. Oh, just call it column, I guess. 11 colon do 1. Yeah, why not? And then you get 1, yes. And then the value, you get 10. And then you set that one. Brilliant. Put. Okay, now a fourth one. This is a native one. Look at that. Yeah, let me put the logs for the native one. Native. Yes, here. The call to native is Interesting. I'm not passing any context path to it. Well, that makes sense. Hi, because I was trying to refactor it before. Okay, but for now I'm not going to use it. Maybe we just leave it like that. Yeah, because eventually I want if and do to be called from here. But it's okay, we can do that later. Now, the important thing is to think. Yeah, what's being passed to this one? Yeah. It's native. So 1 equal 10. The stripper will basically get rid of this second path, and then you have 2, 1. Honestly, I could just do it yeah, the stripper removes the paths with add and removes equals from those the remaining paths. The stripper for cell do is a bit more interesting. Yeah, because it has to look at the first one. Yeah, okay. So it has to have its own stripper. Good. Okay, we have the native there. And then finally we have the put. So our putting do 1 equal 11. So we're resolving the sum there. Brilliant. And then column do 1. Okay. This is a no op here, see? So it's the same path that before. Why don't just copy? No, because there's nothing to do. Respond native, and then yeah, we do respond reference. Maybe I could do this to copy things a bit faster. what I could do here. Boom, boom, boom. Oof, what did I do? Ah, silly. Okay, this is starting to look better. Respond, do, put. Respond, do, put. Respond, reference, put. Respond, native, put. Respond, native, that's the first knob. Respond, reference, oh, this is better. This is way better. Took me a few iterations to get it good, but now I can actually read it very well. Respond, native. That's the first knob, right? Yeah. Respond, native, respond, reference. Respond. Reference. Yeah, if you look at the previous reference, it's the exact same one, right? 11 add one add int, yeah, it's the same one. So you can see that this knob is the knob of what happened here, and this knob is the knob of what happened here. Yeah, it's like, makes sense. Then we have respond and do on what? And then here we have again a do, because it's a execute. Why do it's the same execute as before, right? It should be, right? Yeah, the context is, no, look at that. No, it's a different one. The definition path is plus do. Wait, plus 1, right? Plus 1, of course. So I'm comparing these executions. The path is the same. The context is inside one. And the message, what was the message the first time around? It's 110. Yeah. Yeah, because the outermost is just a list of paths. Do respond. I'm still not understanding what am I running here properly. Maybe we can just look at the diff. We're finally putting the response on top of 11 here. We're done computing 11. Okay. So we start with 11 here. We first put the expansion. So we will start the expansion by putting the message. Then we put the first step. Then we resolve the variable, the reference on the first step of the expansion. Then we make the call to the plus. Then because this gets basically piled on top, then we re-enter and we have the first no up here on the path we just did the plus on. And then we go one down to the reference again, and the reference is a no because it's still the same. There's no knob for the argument, for the message, because the message is just static. There's no reference, right? Yeah, because we place it directly. That's an interesting consequence. And then finally, we get the value because we're done, because it's finished. So the message is the same, the sequence is the same, and then you just put the result. Beautiful. It's not that inefficient, honestly. Not bad. Okay, so the sequence for the first path is done in 7. To respond. Which are, yeah. Initialize. Put the message in the expansion, and then what was it? Why can't I memorize this still? Yeah. Put the first and only step of the sequence in the expansion. Solve the reference on the first step of path of the first step of the sequence of in the expansion. Yeah. Make the native call to plus. Enter and get a knob on the path with the call to plus. Re-enter and get a knob on the reference on the first path of the first step of the sequence in the expansion. Nice. Repeat again the original path 11 at plus 1 10. Execute and now get a result. The result of the last step of the sequence. So that's how it works. Interesting. Why is there so much below? Because it goes from the top again. After this happens, the following happens. I can start one again. No, you're not. Native knob again. Native reference knob again. Let's clarify a knob is when the current value and the new value are the same. No need to do anything. Just proceed down the data space. Let's just get some Dr. Hein. All right. And here we get a knob. Execute knob for the first time. And finally, we get to the other one. It's also interesting. I need to write this down. Let me just put the marker here. Oh, that's a long way to go. Oof. What did I want to do? I just forgot. Ah, yeah. No, wait. I kind of forgot and I kind of remember. It's about, oh yeah. Interesting that you can already execute something whose definition hasn't been expanded yet. By definition, actually responded to. For example, the response of class 1 itself would be equal 1. We don't need that to be there for us to actually compute the call, the sequence actually, because we just read what we need from solver. Sure. So we execute the knob for the first time. Perfect. And then we hit plus. Finally, we go and expand plus 1. It would be then we define and then we do the put. So at this point, technically, we're done. We're done. At this point, we'd be officially done, but we are going to go through the entire cycle again, but with knobs. Let's see. This is the last put, right? Yes. So let's mark the last put and see if there's any other puts. There shouldn't be. Oh yeah, there's another one. Interesting. Why? Okay, we're going to learn something here then. Okay, so we go here from the top again. There's a put below. Let's get surprise. Native knob for the third time. Respond native, respond reference knob. This is a good example, by the way, that captures a few things. For the third time, says execute knob for the second time. Yeah, this is what's wrong. This is just wrong. There should be no puts here. It's calling the definition again. Wait. Yeah. How is this put? Where is this put coming from? This should be a knob, right? Why are we overwriting the value of 11? That makes zero sense. Where is this put coming from? Okay, be right back. All right, let's keep on going. So we have this mysterious put, and I'm starting to suspect that it comes from the fact that now, if you do a reference on +1, you're gonna get the result. You're gonna get int 1, the name of the message and the length of the sequence. But I don't see, I mean, this should be from a re-entry. So I don't understand where this put is coming from, really. So I have the one from the cell call, which is not a thing anymore. I have this one. Sorry. Okay, 3 places. Good. From 1. How can the definition make this call? What happens with define? Because the definition sets a value. But first of all, I lost it. Yeah. Why does it do it on 11? That's what's driving me nuts. Has no business calling anything on 11 right there. Wait. I'm an idiot. It's responding again this one, right? How do I quickly find the knobs? I need to find the plus when it's dealing with plus for the first time. Or I can just count the response. Knob, knob native, knob reference. No, wait, that's not a knob. This is the first native. Knob reference. Putting the results. Then again, third one, second knob. And this is the last one, the one that should be the last one. But how did I, where's the X? Yeah, so we have 3 knobs now. I'm lost again. This is a bit tricky to measure, honestly. Native reference. Result. I need to count from the top. That's no, otherwise I'm just not sure what I'm looking at. There's too much uncertainty. Sorry. Okay, multi-lab, where are you? This one. Okay. Here we go. No, this is the diff. This is the original one. Okay, now we start. Okay, first respond. 1, 2, 3, 4. The fourth is the native, right? Yes. 5 knob, 6 knob, 7 is the get the result. 8 native reference, and then execute knob also for the first time, and then finally we expand +1. That's a step 11. Then we get 3 natives, 3 knobs: native, respond, undo. Yeah. Why, when I'm defining this, modifies 11. It's just so mysterious to me. I just don't get it. It's where I was before, when I confirm that's the case. It's a 17th respond here. And by the way, the final data space looks like this. You can look at this as having 4 paths that you need to be responded. Only here we expect a knob for the first time on the definition +1, but we get a call to replace 11 with 11. This is wrong, but how? The final data space will look like this. How many is it? Oof, almost 15. But here there are only 4 paths that are first paths. In that they have calls that have to be checked. Those are 11 plus 1. No, sorry, the ones with add, it would be plus. So it would be colon do actually it's like this, do that would be actually the one with equal 10, of course. This native, this reference, actually let's do it like this. Hasanat, 11 plus 1, 10, sequence, plus 1, do int. This is pretty beautiful. I never saw it with this level of clarity. Path now, first calls, and stand for other paths with a similar call prefix. Now we can switch the music a bit. Also Scandinavia. So what? So it would make sense to have 15 steps, because you start here, start at execute sequence and add message, that's 2, 10, add sequence step. Then resolve reference. That sounded like somebody knocking on the door. Except I don't see anybody. Never mind. So where were we? Yeah, I think this didn't work as well. So message. No, the message is and then native call is for when we are here, all the first calls, or should we call them call prefixes, are there. So if we go from that perspective, because I'm trying to induce from here, so you resolve one, now you resolve another one, because this one goes on top of this one, so this one goes on top of 4, goes on top of 3, and then you go 4, 3, then you hit the third call, the third call prefix. Yeah. At the end of step 2, all the call prefixes are there. It would be then what happens is it native just a no, it's just 3 call prefixes because int is not expanded yet. Sorry, it's this one. After step 3, we do have all 4 call prefixes. Then we respond to the first one. That's 4. With native. Then get no ops. Wait, I don't understand why do I get a native no op immediately afterwards? Ah, yeah, you do, of course. On native reference 6. Then we can respond to the third call prefix. Because there's a change, we go back to the top and get 3 knobs, which is 8 to 10. Okay. Then we finally expand +1. Then we go to the top again and hit 4 knobs for all of the call prefixes. This should be the end of the response. I really like this, actually. It's very pretty. So why the hell do we not have a final thing there? I like how I'm developing intuition finally on, okay, a call prefix gets placed on top. The mechanism of expansions, never mind the bug that we'll solve. Yeah, because I don't think this is a discovery, just a bug. Is that the expansion of a call prefix can put other call prefixes on top. Once any of these hit a change, we just go back to the top. Even when we have dependencies, a similar mechanism will happen only on a smaller amount of paths, and what's the top will depend on the dependencies. Nice. So what? Did I mark it or did I lose it? Oh no, not again. It's this one, right? No, because I have respond 11. No, see, here's another one. Yeah, this is the one that's wrong. The first diff. No, it's not the first one. You see it again here. And then you replace it again with the proper value. You see it here again. Just silly oscillating there. But it's oscillating because it did the wrong thing. Something I could do to find myself in this maze. Just a minute. Okay, once more. These counters will definitely help, I think. Okay, 275 plus 16 is 291. or 290. Why that doesn't make sense. Yeah, this is the first one. How many did I say it was? 15. Oh yeah, so it's plus 14. 299. No, sorry. 289 is the last. 289 is the one that should be an op, and it's not. But why and how? How can this make a put? That makes zero sense. The new value is there. I guess there has to be a, but there's no re-entry, because see how we don't go to respond to. It's not that we are doing this one again. Why is 11 being set? How can this? That makes no sense. Because what does define respond with? It's just the actual message name and length. That's it. That's all it responds to. Responds with. That's it. Maybe. Yeah, because there's no put here. It has to be something that's bubbling up, not bubbling up, but just being responded to. We said it was 290. Oh my, this is so useful. This makes zero sense. Ah, because it's hitting this. No, wait. Why do I get this path here, but this path here? That I don't get it. I'm not changing the path anywhere, right? How can the path suddenly change to this without re-entering? I don't get it. I mean, at least it explains why it's covering, like doing this. What it doesn't explain is why don't see another call here to respond. I don't get it. Why is the put coming before? Unless it's a timing thing. But no, look, this is this. This is not at the top. No, it's something weird. I'm not editing path at all. I'm not touching path. Let's just disambiguate this 1 sec. $290, right? Get 289. Yeah, this is all correct. It's fine. Do no, the mystery is why this. By the way, this is the issue probably. Empty versus this empty. But why is it not appearing like respond 290? That's what I don't get. Maybe it's because one is slower than the other. I don't think so. Okay, I might be back later. I might be back next episode. Thank you for watching.